This video describes the Proto 16 I2C card designed by Landboards. Here's the overall view of the Proto 16 I2C card. The card is compatible with any modern microprocessor that has an I2C bus and runs at either 3.3 volts or 5 volts. This would include Arduino, Raspberry Pi, and BeagleBone Black. At the heart of the card is a microchip MCP23017, which provides 16 bits of I/O and is controlled from the I2C bus. The card contains a pair of I2C interface connectors. This is a two-wire interface, and the pair of connectors allows for daisy chaining two cards together. The card has I2C address select jumpers, which set the offset address of the card and allow multiple cards to be used. The card can be powered through the I2C interface connector or through an optional power connector. We designed this connector to be reversible to reduce risk of damage. The card has a personality or configuration EEPROM which can be used to store particular information about the use of the card. There are jumper selectable I2C terminators for terminating the last card in the I2C chain. There's a jumper to enable or disable writes to the EEPROM to protect against accidental erasure. Card power is routed to the I/O connector through a self-healing polysilicon fuse. The fuse can be overridden by a jumper for higher power uses. I/O connections are made through an industry standard DB25 connector. This is an inexpensive and widely available connector. Here's a rotated view of the card to help us get a better look at how the prototyping area is wired. At the top of this view is the MCP23017, the 16-bit port expander. At the bottom of the view is the DB25 I/O connector. The area in the middle is the area in which you'd prototype your circuit. The top row of holes connect directly to the MCP23017 I/O expander chip. Similarly, the bottom row of holes connect directly to the DB25 connector. The center section is wired very much like a breadboard, and this is where you would prototype your circuit. Let's take a closer look at this prototype section. Again, the top row of pins connect up to the MCP23017, and the bottom row of pins connect to the DB25. Both power and ground are bused horizontally across this prototyping area. This leaves 3 pins on either side of the power and ground, which are connected together in a bus to allow multiple components to be connected to the same electrical node. Let's take a look at what it would take to implement a fairly simple circuit on the Proto I2C 16 card. For this example, we're going to put an opto-isolator on the card and have the input to the opto-isolator come from the DB25, and the outputs of the opto-isolator go to the MCP23017 port. Here's the card with the parts that we use to implement the optocoupler circuit. We've also added another resistor to pull up the output that goes into the MCP23017. Here's the circuit on a typical breadboard. Although this is a simple circuit, wiring can easily get very tangled and complicated with a breadboard, and it's easy to bump a wire loose. Here's the same circuit installed onto the Proto 16 I2C card. As you can see, the wiring is very simple and clean, and it'll be rigid and solid. The only connection that's on the rear side is the one that connects the LED's ground to the bused ground across the card. We here at Landboards want to thank you for watching our video and hope you'll consider supporting our products.